Hello, welcome to Chapter 2 of Astronomy. Now, the second chapter in this text is titled Gravitation and Motion of the Planets. Now, this second chapter, the title I think is a bit misleading because we do get into gravity and motion of the planets, but the first thing that we're going to look at in this chapter is actually a little bit of a background about how we got where we are in terms of our understanding of gravity and the motion of the planets. And what that means is there's a little bit of a historical context that comes at the beginning of this chapter, talking about how do we know what science is, and how do we build theory, a hypothesis into a theory and into laws, that sort of thing. But really the thing that I want to touch on first is on 43, talking about changing our view of the Earth-centered, or what we call the Geocentric Universe. And it was around 400 years ago that this idea of the Earth being the center of the universe kind of started to evolve into us understanding that the Sun was the center of our system. And then since then, our understanding has changed significantly beyond that. But the idea of this change happened for a very set number of reasons. And really it changed because of what we now call modern science or modern astronomy. That is, observational-based data driving our hypotheses, that we can actually observe and gather information to make good ideas. But nonetheless, this idea, and I'll explain it very briefly. The idea was that there was one small problem. Really, the whole idea, the whole idea of the Earth being the center of the universe works really well if you go outside and look. All right, that's what it looks like. If we go outside and look, it looks like everything is going around the Earth. We don't feel motion. You don't feel wind moving around us as if the Earth is spinning in one direction. We don't feel vibration we usually associate with motion. There is no feeling of movement, but yet we are constantly moving. Everything is moving. But it took many years and a lot of good ideas to overcome this idea. Now, the idea, the problem with the major idea is shown for you here on the top of page 43. This is the path over many nights of the motion of the planet Mars in the sky. And Mars, like Saturn, Jupiter, and Venus, and Mercury, make up the five, what were originally known the five planetes, or what the ancient Greeks called wanderers. We noticed them moving in the sky. They moved from night to night. They didn't seem to stay in the same spot. And so we have known since ancient times that those five objects were not stars, that there's something different. And they moved. They had to be closer than the stars. And this has been understood for many centuries. But the problem was that this motion is not uniform. And in fact, what happens is that it goes one direction, it stops, and it goes back another direction, and then goes back again. This motion of moving backwards is what we call retrograde motion. And this one seemingly small problem in terms of the motion of the sky, believe it or not, would wind up being one of the major pieces that totally unraveled the idea of the geocentric universe. Because this was originally dealt with by using a thing called an epicycle, and they explain epicycles on the next page about how they worked. And epicycles were a method used to describe this for many centuries, since the ancient Greeks described epicycles. Ptolemaeus is credited for coming up with this model based off of the teachings and the ideas of Aristotle. So you're talking about like 2,000 years ago plus is where this idea comes from. And it wouldn't be until really the Renaissance era that we would start to change our idea of our understanding of how this works by saying, no, it's not an epicycle. It's that the Earth is not the center, that the Earth is going around, the Earth is moving as well as everything else. And so that changes our perspective. And so they show you this nicely on page 45 explaining this motion. Now, why does all of this matter? Because all of this was the beginning of our change in our understanding of how the universe works. For many centuries before the time of Copernicus and Galileo and Kepler and Tycho Brahe, the area beyond the earth was just considered the heavens, and it was supernatural, and we couldn't understand it. We now have a very good understanding of what goes on beyond the earth, and we have only continued to gain more understanding as we have looked more and we have studied all the more. But the idea really began with Copernicus, Nicholas Copernicus. He's the first guy to really come up with the idea that maybe the earth is the center, and he was the first person to put this idea out. And there's a lot of interesting information about all of these characters. But Copernicus knew his idea was going to be controversial, and so he actually held off putting out his information until basically he was on his deathbed for fear of retribution. And then sort of the generation after him, we see three main characters that really come into play. Tycho Brahe, Nicholas Copernicus, and the guy who is probably the most well-known is Galileo Galilei. These three characters all worked intensely during a time of very great scrutiny to try to gain real observational data and analyze that data to figure out the answer. Is the Earth in the middle, or is it the Sun in the middle? And how can we know? And of course, Galileo is credited so much with his use of the telescope. And make sure when you do the reading in there, you'll notice that Galileo did not invent the telescope. Galileo used the telescope for astronomical purposes, and in doing so made a variety of just game-changing observations. Interestingly enough, Galileo's decision to do that in 1609, in the winter of 1609, this idea of using a telescope to look at the sky changed the game. That moment changed everything because he brought to it this seemingly incomprehensible idea. He brought to the game technology. And it was technology that has allowed us, since that time, we have not stopped doing that. We have not stopped adding new technology to this game and have only furthered our understanding. And Galileo is the person who gets credit for first doing that. Now, at the same time, there was Tycho Brahe and along with him, Johannes Kepler. Tycho Brahe ends up being a really fascinating character. I tell you, if you want to read about a really unique character, I'll just put it that way, go look at the Wikipedia page for Tycho Brahe, and you'll see he was an odd character, but nonetheless, a great astronomer, made wonderful observations, had a lot of really good data. He unfortunately lived a lifestyle that, let's just say, didn't exactly contribute to a very long, healthy life. And so when Tycho Brahe died, the information went to his understudy, who was Johannes Kepler. Kepler took that information, took Tycho Brahe's very precise data, and Kepler is the guy who comes in and brings the smoking gun. He's the guy who figures it out, who puts together the one big thing that helped us understand what was wrong. And our one big thing, the one big problem that we had assumed for all of humanity is that the objects in the sky were moving in circles. They do not move in circles. And Kepler proved it. He proved that they actually move in an ellipse or an oval, slightly elliptical, very, very slightly. But they are not perfect circles. And because they don't move in perfect circles, that changes a variety of things about their motion. So what happens is Kepler ends up being the guy who provides the math to go along with Galileo, who had the observations with the telescope. So it was sort of the combination or the crescendo of these minds working together started to really cause people's minds to change and realize, well, maybe this works a little differently than we thought, and maybe our understanding of the universe is going to have to change. And sure enough, it wasn't long before it changed. And the next character that really comes along in the next generation, and that's Isaac Newton. So you have Copernicus, you have Kepler, Galileo, and Tycho Brahe, and then you have Newton. Sort of three generations here of people working on this problem. And Isaac Newton is credited for many things that many people know about. For example, the laws of motion. He's also the inventor of calculus. He did a lot of work with light. The thing that we need him most for in this chapter is his work on gravity and his explanation for what gravity is and how it works. And you see, Kepler, when he made his game-breaking discovery of things moving in ovals, he still had the big question of, why do they do that? And he understood, the math told him, this is the way they move. We can observe this. We can measure where they are, and we can prove they move in an oval. But he had no idea why. It is Isaac Newton who comes along and says, aha, I think I know why it's doing this. It is this fundamental force we find in nature called gravity. And he explains in wonderful detail, and the book goes through this nicely. The Gravitational Force on page 60 explains what gravity really is. Now, many of us probably learned, I remember when I was in grade school, my grade school teachers, my fourth grade teacher said, gravity is what keeps you in your chair. Gravity is what keeps you from floating away. Well, yeah, that is what gravity does, but that's not what gravity is. What gravity is gravity is an attractive force between any two things with mass. Let's think about that for just a second. That means that my body has mass, right? And so does my ink pen here, right? So that means between my body and this ink pen, there is an attractive force. Now, I don't feel like there's an attractive force. I don't feel like the pen is being, pulled towards my body. In fact, if I let it go, it doesn't go to my body. It goes down, right? And this concept actually was tremendously controversial until Newton explained this as to how it works. Because you see, the amount of attraction is related to the mass in the object and the distance between them. Turns out, this pen nor I have very much mass compared to something else. What it is that does have mass, and a whole lot of it, is of course the entire planet Earth. The Earth has a tremendous amount of mass, and therefore it has a tremendous amount of gravitational attraction, holding you and me and everything else we have near the surface on the surface. It is pulling us down. In fact, it's trying to pull us to the center. The center of mass is where it acts upon. The good news is the crust of the Earth is a hard shell, so we don't get pulled through it. But this gravitational attraction not only works between me and the ground, or in the story of Isaac Newton, many people know the legend of the apple, the apple falling from the tree. A lot of the actual reading says an apple probably never hit Newton. It's probably that was one of his examples. But nonetheless, he used that example to say the attractive force, that why an apple falls from a tree, is the same force that attracts the Earth to the moon. And then that must be the same force that attracts the Earth to the sun, and Jupiter to the sun, and so on and so on and so on out into the universe. And so what he did by bringing us gravity is he provided the mechanism to explain all of the processes we see throughout the universe. The whole cosmos is filled with gravitational interactions. And without gravity, none of the things that we really look at out there actually work. Now, later on when we get to the end of this course, we'll realize that gravity's got some other questions we got to figure out, some things that we don't fully understand about how these big structures work. But gravity works very, very well when we're talking about objects moving around in our local neighborhood. We can easily understand how they work, we can calculate it, we can predict it, and we can figure out how they work. So, those are the major critical parts of understanding how Chapter 2 works. So, make sure you go through the reading on this. This is a short chapter. It's a quick read. Take a look at the PowerPoint associated with this chapter. And then you'll be ready to start the homework for Chapter number 2. Good luck.